Halo, selamat sore semuanya. Welcome to GDG Jakarta Talk Series. Apa kabar semuanya? Semoga teman-teman dimanapun kalian berada sekarang, semua dalam keadaan sehat semuanya. Walaupun sekarang kondisinya lagi pandemi, lagi naik kembali ya. Tapi kita tetap harus semangat menjalankan aktivitas dan juga mencari ilmu dan pengalaman baru pastinya. Nah, kita kembali lagi nih di acara GDG Jakarta Talk Series. Sebelumnya, perkenalkan nama saya Hana Faikoh, biasa dipanggil Hana. Dan di sini saya akan memandu berlangsungnya acara hari ini. Oke, kali ini kita akan mengangkat sebuah topik yang sangat menarik, yaitu How does DKatalis do machine learning? Nah, pasti teman-teman di sini adalah orang-orang yang tertarik ya dan minat dalam bidang machine learning ini. Nah, tenang aja karena hari ini kita kedatangan dua narasumber yaitu Benjamin Tan dan Varun Mallya sebagai senior machine learning di Katalisnya sendiri. Jadi pasti semua teman-teman di sini pada penasaran dan yang pastinya nggak sabar untuk mendengarkan pemaparan dari mereka. Okay, so let me give you a brief agenda to today's session. Jadi sesi ini akan berlangsung selama 50 menit dan setelah itu kita ada sesi Q&A. Setelah itu kita ada foto bersama dan kemudian closing. Jadi cukup singkat acara hari ini. Before we start the session, selama sesi nanti jangan lupa juga untuk memberikan pertanyaan kepada mereka melalui chat box yang akan saya baca nanti ketika sesi Q&A. Jadi jangan lewatkan kesempatan ini ya teman-teman karena bisa jadi ini tidak terulang kembali. Okay, wow, I bet everyone is excited as I am and cannot wait to hear words from our special guest today. So today we have Benjamin Tan and Varun Mallya as Senior Machine Learning Engineering at DKatalis. All right, everyone, show us your excitement by giving us your best emoticons in our chat box. So let's greet our speakers for today. Welcome, Benjamin and Varun.
Hello, thanks for having us.
Hello, I'm
Hello,
doing
guys. All right. So you may start your sharing session now.
Okay, cool. So let me. Can everyone see my screen already?
no.
Not yet.
Ah,
All
Yeah.
right,
there we
it's
go.
starting. All right.
Perfect. All right, cool. So thank you, Hannah, for the introduction. So thanks for taking the time to attend our talk. I'm Benjamin, and today joining me is Varun. So we are both machine learning engineers over at DKatalis, that we affectionately call DK for short. So as way of an introduction, DK functions as the engineering arms that create the Jago Digital Bank app, Aman's Digital Sharia, and a lot more digital solutions to come. So what Varun and myself are going to present today is a really high overview of our ML architecture that we have implemented over at DK. And not only that, we're going to be slightly more concrete by describing some of the tools that the data science team use on a daily basis. And then follow on, we'll provide two examples of machine learning within DKatalis. And then, finally, it's your turn to do the hard work by giving us your questions. So we'll start with the ML platform architecture. But even before talking about the ML platform, I think it's worth mentioning why we even bother building out a machine learning platform in the first place. At least for DK, what we wanted first and foremost was a platform to support our data scientists so that they can easily experiment and train machine learning models. But that's really just one small part of the overall machine learning flow, since model training is just one small piece of the puzzle. What we also want to consider are things like data versioning, feature storage, continuous model training, parking models in the model registry, along with its artifacts, model monitoring, and observability. And as a platform, we should also be flexible enough to handle the different use cases that we might not have considered yet. So the main technology choice that we have adopted is Kubeflow, and it forms the backbone of the ML platform. For those who are not familiar with Kubeflow, it's a machine learning toolkit that runs on Kubernetes, and it's not a single piece of software. So just like any toolkit, it comes with a bunch of different software packages, and a lot of them would already be familiar by data scientists. So things like Jupyter notebooks, TensorFlows, which is also, and also, the certain machine learning library developed over at Facebook. So, many of the tools cover the training, machine learning training aspect. But there are also things like Kubeflow pipelines that help automate the machine learning flows, tooling such as Kserve that help with model development. So Kubeflow has the tooling that handles pipelines, training, and deployment. However, you might notice that even though Kubeflow provides quite a number of tools, it really is not the end of the story. So here's a high-level overview of the machine learning platform that we have deployed over at DK. Everything over here is deployed on the Google Kubernetes engine. Otherwise, we weren't allowed to come and speak at a GDG meetup. But besides that, you'll see that we have other components, such as Feast, which is our feature store that Varun will talk more about, popular data processors like Flink and Spark, Mlflow, which handles things like the model registry and artifact tracking. So the point I'm trying to drive at here is that you're free to customize your machine learning platform as you see fit, and you shouldn't be constrained by what Kubeflow does or does not provide. So by way of example, we found that for the model artifact tracking capability of Kubeflow not to suit our needs, so we decided to use Mlflow instead. Here's a relatively comprehensive list of what we are currently using on the ML platform. You'll notice that some tools were not mentioned in the previous diagrams, things like Knative, which we use for model deployment alongside Kserve, and things like the usual Grafana and Prometheus combo for monitoring and pretty charts, and finally Argo CD for continuous deployment. So let me quickly take you through the UI of Kubeflow, because sometimes looking at architecture diagrams can be too abstract. So here's the central dashboard, and if you look at the menu, that's where you'll be able to access things like pipelines, notebooks, AutoML experiments, etc. And this is what a running pipeline looks like. So just like any pipeline, this is defined as a DAG, a directed acyclic graph. And you can either write it using the Python SDK or use pre-built components. Pipelines are then compiled into YAML and uploaded via the UI. Or if you want to use the SDK, you are free to do that. As mentioned, Kubeflow comes with Jupyter notebooks built in, so you can do all your EDA stuff to your heart's content. For TensorFlow users, you'll be happy to know that it comes with Tensorboard built in. And this is an example of model training data that's being fed into your model real time, which is something cool that Tensorboard provides. And this is Mlflow, which Varun will speak to you more about. It provides a really nice and simple UI that tracks all the hyperparameters and important artifacts for your model training.
Yep. Thank you, Ben. So Mlflow is one of the other tools we have in our utility builds. The Mlflow project is an open source project which was built by Databricks. It is used to maintain the whole machine learning lifecycle, and it itself has 4 separate modules. The most popular of them is the Mlflow tracking. Now, in earlier days when we used to build models, obviously you would run multiple iterations of it, try different hyperparameters, and try to finally find out the best model which you can use to deploy to production. Now, keeping all track of all that metadata is definitely not easy. Excel sheets don't just cut it. And that's why we have Mlflow tracking. Mlflow basically provides you with simple APIs which you can use to track your experiments and each run. So whenever you change something, you can track it on Mlflow, and finally you can select the best model which you can then deploy to production. Then we have Mlflow projects. Mlflow projects is basically an easy way in which we can share projects amongst each other, a reproducible format which has a simple template and which specifies the environment files, etc., and which you can then use the Mlflow APIs to deploy quite easily and get deterministic results every time you run it. Next, we have the Mlflow models. So we can build models using multiple frameworks. It can be scikit-learn, XGBoost, or TensorFlow. But having one common format which is easily deployable is something which Mlflow models provide you. We can just have one format and we can serve it using the same consistent APIs, again, which Mlflow provides. And finally, we have the Mlflow registry. The registry is nothing but a backend where we can store all the artifacts which are generated during our experiments, made the models or any pretty graphs or any confusion matrix, etc. Basically, any file format would do, to be honest. Yeah, so the next slide, please. Yeah, let's just talk about a common use case of a data scientist working with Mlflow, right? So all great things are done on Jupyter, and that's where the ML code lies. And basically, the data scientist writes his normal code as he always does. And we just have to input the Mlflow part of the code, which is like a tracking API and basically some log statements. And once we do that, we can see that the experiments get logged in the Mlflow UI, which is, by the way, a part which we have made as a part of Kubeflow UI 2. Once we have that, and once say you have run multiple runs, you have found out the best model, you can then use the Mlflow model registry to register your model. And this can be version controlled. So you can have multiple stages. Like you can have one model running in staging environment while the other model running in production. And eventually you can pull that model and you can use it either for your batch pipelines, like a Kubeflow pipeline, for example, or you can use it for online serving too, like Kserve or even Knative. Yeah. So let's move to Feast, right? So this is a very common use case, like a common data set, you can say. You have customer IDs or user IDs or device IDs, and then you have features which are about that customer or about that user. And most of these features are aggregated, transformed respect to some timestamp. Now, feature computation is not trivial. There are a lot of transformations done and a lot of aggregations performed to actually arrive at those features. And we can imagine that deploying this to production and may not be, and passing over the code may not be something which is that easy for from data science to machine learning engineers. And Feast or a feature store comes into play here, right? Yeah. Excellent. Right. So again, why do we need a feature store? Now, it's in an organization like DK or any large organization as such, it is quite possible that there will be multiple data scientists. And once you do have that case, there's a high chance that the same features can be reused by them. And instead of them defining them one by one, we can just have one common source of definition where the data scientists can continuously reuse those features. It also makes sense to have a online as well as offline view for features. It's not necessary. We can support for both use cases of batch versus online. And a feature store can actually help us to make sure that both the online and offline stores of data are consistent. And to make sure that our features are fresh and not stale. For example, in case of customer data, we would want to make sure that the aggregations performed are fresh and are not out of time. Feast has APIs which can help us to abstract those point-in-time joins, which otherwise would have been quite complex SQL queries, right? And the feature store also should support low latency online serving. Basically, when in online use cases, the feature retrieval should be quite easy. Yes. So again, a Jupyter notebook. Basically, this is the Feast workflow. You use basically you define your features first, and you compute your features, right? And then finally you arrive at that table on the right. And once you have that, you basically have to store your features in a certain store. Now, this will be an offline store. It can be a file system, or it can also be a BigQuery. In our case, we are using BigQuery, right? And once you compute your features and store your features in a backend, you basically have to specify a feature definition file. This basically tells information like what is our entity. In this case, it may be customer ID, and what are the features, and where are we storing our features. Once Feast gets that information, you just have to press Feast apply. And what this does is that it registers the features and the entity, and it ensures that these features are suitable for being retrieved during inference as well as training. Right. So splitting these our ML lifecycle into two main steps of training and inference. We'll have our entity table. This is the table where we'll retrieve our customer IDs or user IDs from, and then we'll have our feature tables. Mind you, we can have multiple feature tables. We can have feature tables stored in multiple features. And basically, Feast supports an API where we combine these two entity tables and the feature tables, and we can eventually get a training data frame. And this ensures that we have the freshest set of features for the entity that we are looking for. Once we have this data frame, we can then proceed on to model training and basically build a model. And finally, when we have that model, we'll deploy it. And that comes the inference side of things. Now, let us consider that the inference is basically an online inference, right? And you can imagine that if our features are stored in BigQuery, retrieving them from an offline store and performing those complex joins are not that easy. And that's where Feast helps us to make sure that we can move that features from our offline store to our online store, in this case being Redis, right? And it has a commands like materialize increment, which can ensure that our online store is up to date with the features which have been computed. And the multiple runs, we should just run this multiple times to ensure that the features are always fresh. Yeah, so this is an example of how we retrieve our training data. Basically, we have a query which the entity query, which is the user, the query which gives us the customer IDs, and then we have our features, basically telling that this customer will be joined against this feature, and then we will have a training data which can then be used for training purposes. And this is from the Feast website itself. Basically, Feast, again to point out, is not itself a data store. We rely on backend data stores like BigQuery or GCS for storing of data. Those are the offline stores, and then we'll eventually have something like Redis or Memcached, which can be used for online feature retrieval. Feast is still a work in progress. Like streaming sources have yet to be supported, and the validating and monitoring is still to be done. But the feature store itself is quite promising, and we have faced no major issues till now by using it. Thank you.
Cool. So now I'm going to give you one of the use cases that we have been doing in DK that's related to ML. And one of the things is KTP OCR. So I'm pretty sure as Indonesians, you guys are already familiar with what KTP is. So as a bank, for us, onboarding customers using the Jago app, requires the digitization of important documents. So, things like KTP, your passports, or, any interesting text forms. But by and large, for us, approving customers, the main document that we're using is KTP. So it's important for us to capture this information as accurately and as quickly as possible. But, even before thinking about a machine learning project, you need to remember, how are you going to get your data from? And that's where annotations come in. So, without annotations, it would have been impossible to build out a meaningful OCR solution because there's no way to access the accuracy of the OCR. So this is exactly where we started. We deployed an annotation tool. We enlisted folks in the company to help us with annotating thousands of KTP images. And from there, it's just a small matter of training and evaluating and tweaking the model. But up to this point, we have not used any of Kubeflow's tooling yet. But we'll need it when it comes to model deployment, which is what I wanted to show you. And for model deployment, we use a toolkit called Knative. It's essentially a Kubernetes-based platform used to deploy and manage modern serverless workloads. And it's cool because it ties in a bunch of features together in a simple single YAML definition. So, if you are familiar with Kubernetes, this single YAML gives you things like pod definitions, scaling, routing, and traffic management, which, if you do it by hand, you're going to have multiple CRDs all over the place. And in our OCR services case, the top of the YAML looks like that. The tolerations field at the bottom specifies that the OCR service would run in a high CPU node pool. So this means that we have already pre-provisioned a node that has this high CPU and we have labeled it appropriately. And this is especially useful when you're deploying high CPU workloads like that, because this means that the OCR service would have exclusive access to this node pool. And another interesting thing is the annotation at the top, which specifies how Knative should scale up or down the OCR service based on demand. And this is cool because Knative also lets you set the conditions as when to scale up or down. But again, this really depends on the characteristics of your workload. So there's really no magic involved, and it's really up to the developer to understand what your workloads are and set these conditions as needed. But the cool thing about Knative is that, deploying the service, like deploying the OCR service, is just a single command. And Knative assigns a URL once the service is reported as ready, and then, you're good to go. And Knative already exposes a bunch of metrics by default. So as a developer, you just need to figure out the PromQL, the Prometheus query language, to generate the pretty graphs and gauges.
Yes. So this is another use case for anti-money laundering. Recently, Credit Suisse was caught for apparently helping in processing transactions for the Bulgarian mafia. Yeah, I mean, the thing is, there no bank obviously wants to be involved with money laundering activities. You do not want to be a playground for laundering money, because apart from litigation, it also has a bad repute, which is more difficult to probably get rid of, right? But say from a money point of view, so usually a lot of people are hired as investigators, and the main job of these investigators is to like investigate the possible cases for money laundering. And basically you have most places you have rule systems which you can identify it, and then we eventually spend some time in investigating, and that involves a lot of people. And this is where machine learning can actually come in, which can help us to more precisely flag out the AML cases and eventually save a lot of dollar and effort, right? So yeah, I mean, just moving on how to actually deploy a model like this. Next slide. Right. Again, so for our case, let us think of the AML pipeline as a daily job, right? Basically, we have a tables where AML cases are populated, and we read from those cases and eventually specify what is a true AML case or not, right? And what you can see here are two specific Kubeflow pipelines, and also we're using Feast and Mlflow. Basically, let's talk about the first pipeline, is the AML backfill AML features. So, like I mentioned, we have registered our features in Feast. We have stored them in the BigQuery table, and we have to run a job which will ensure that these features are computed periodically and are more as relevant for the customer as possible. So, essentially making sure that the features are fresh, right? And this runs periodically, a daily job, which Kubeflow pipelines orchestrate. And then we have the inference pipeline itself. So you can see that the steps are quite generic to almost all ML pipelines. You have fetching the data, you're transforming the data, you perform inference, and eventually you write it to another BigQuery table, right? And while fetching the data, we usually fetch it from using the Feast API provided. Basically, we are getting get historical data, and once the feature tables have the proper features, we retrieve the data there, and then we proceed to do some transformations. And finally, we have perform inference. Now, for the inference side, we'll need the model. And this is where Mlflow comes in. The Mlflow model registry hosts the model, and based on the version, we retrieve the version of interest and use that to perform inference. And once we have performed inferences, the last step is writing to BQ, the BigQuery. Uh, Basically, all these boxes that you see, they're running in their own separate images, and they are completely isolated from each other. And yeah, so that is a simple use case of how money laundering is handled here.
So yeah, I mean, that's, we're just trying to give you a flavor of some of the machine learning problems that we are handling. So it's not only limited to things like money laundering, fraud detection. We also have things like we should require images, so things like Ktp Ocr. But we have also other kinds of machine learning problems that are coming up. So things like involving figuring out what things the customer likes. So it's quite exciting and interesting, the varied kinds of problems that we're trying to solve. And at the same time, at the back of our minds always is how can the machine learning platform support all these kinds of different use cases. So we've come almost to the end. But before that, I think one of the questions that are asked often is, how how do you get started to be a machine learning engineer, or how do you even what good resources are there? So obviously, I must plug the DK blog. We are actively growing a catalog of posts, and I would love everyone to take a look. And if you are trying to figure out what things do MLE engineers, at least at DK, work on, I think the blog will be an excellent starting place, because we try as much as possible to put in our thoughts, put in interesting things that we've learned along the way, as we're developing the machine learning platform and solving interesting data science problems. But not only ML stuff, right? It also covers a range of topics from product design, software development. and also obviously ML ops and data science. And you might be wondering how you could get started with Kubeflow on your own. And one option would be to install a lightweight Kubernetes distribution such as K3s or even Kind, which is Kubernetes in Docker. And then after that, you can install Kubeflow on top of it. So see the link on top for more info. But a caveat would be you need a relatively beefy machine in terms of RAM and CPU, because even when you install Kubernetes, it's going to be take quite a heavy load on your machine. There are not too many ML ops books yet, and but I think this is one of them which is pretty good and obviously won't be outdated once it's being released. This has a slant towards Google services, which is great for this audience. So I think you guys will obviously find this pretty helpful. So yeah, if you are interested in solving interesting problems, DK is always hiring. So that's it. I think we are happy to take your questions. Thanks so much for your attention.
Thank you.
All right, everyone. Thank you so much for the sharing session today. I think we will continue to question and answer session. So let's see if we have questions. Okay, since there's still no questions from
Yeah, I see one question popping up at the bottom. So it says, how DKatalis handles machine learning model
how
deployment and make it
DKatalis
scalable.
handle machine learning model deployment and make it scalable. Okay.
Kubernetes is magic.
Yeah.
So and that's partly true, right? Because what Kubernetes gives you is facilities to relatively easily scale. And if you need a node with more GPUs, you can provision it. If you need things like more high memory, high CPU, there are ways to do that kind of thing. But obviously, it's not magic. You still need to be to write your code in a scalable way and making sure that you identify bottlenecks as much as possible. Otherwise, given the best machine in the world, you're not going to make things really fast. So the answer to that question is, first, you still need to do solid software engineering to make sure that your code is performant in the first place. Otherwise, it's very hard to scale. The second thing would be then to throw multiple machines at it. So, for example, when we deploy our machine learning models using Knative, we know at the back of our mind that this Knative is battle tested. It's made to handle loads. It can scale up. It can scale down. If we ever need more machines, we can provision them. So the good thing is, we already have the tools to do it, but nothing beats solid software engineering. I hope that answered the question.
Okay, let's move on to the next question. So, all right, there. What is the biggest challenge of implementing Kubeflow and Mlflow in the production? Is there any particular issue? If so, how to handle that?
Varun, do you want to take this, or I can take it?
I mean, Mlflow is thankfully been very nice to us. Not as nice as Kubeflow though. Well, I mean, Kubeflow has been nice. I'm just kidding. But yeah, from Mlflow's point of view, it is a very simple tool. There are which has no issues which you have faced yet, but we may anticipate issues with heavy usage, and that's something which we have to prepare for. But apart from that, Mlflow is working as expected, and it's a great place for, especially when it comes to tracking and model registry. I think it's doing a very good job at that. Yeah, for Kubeflow.
Yeah, go ahead.
No, I'm saying you can mention about go from the Kubeflow one. What all issues you faced?
Yeah, so I mean, if we're talking about like machine learning toolkits, and even it's still tricky because things like data versioning, there's so many products out there that handles part of it but not everything, and it will not cater to all kinds of use cases. And if you look at machine learning frameworks, there are so many different toolkits out there, and at least one of the challenges when we started was to figure out what combination of software and tools would best fit our needs. And that's really tricky, and really it's a leap of faith that you have to figure out and do your prior research to see what your organization really needs, and kind of have a mini crystal ball and project like, okay, what are the problems you are going to solve in the future, what kind of shape that these problems are going to look at, what are the loads that you're going to expect, and from there kind of work backwards and then figure out what you really need. So, but the short answer to that is just install it, give it a try, and then really see what happens from there. And I mean, Kubeflow has and Mlflow has treated us pretty nicely, and the community behind both these software is pretty big. And if you look at Kubeflow and you look at the number of GitHub stars and the number of people contributing to it, it's still a really healthy open source project, and that is really cool. And if you go on like Kubeflow Slack, there are always people with problems, but there are equally number of people who provide solutions and share their experiences. So I think that's really nice also. For us, installing Kubeflow was a challenge, especially because we needed to fit it into our existing infrastructure, right? Because we wanted to make sure that when we install Kubeflow, nothing else would go wrong. So that was quite tricky. But for installation instructions, you can go check out our blog.
All right. So we have a question in the comment box from Rosi Diana Kusuma. The question is, could you explain what kind of pre-processing method DKatalis use in Ktp Ocr, and what's the biggest challenge?
I can answer the second question first. The biggest challenge is people do not know how to take good pictures. And it's tricky because, especially when you're taking freeform images, and as with any computer vision problem that requires an OCR, the backgrounds are going to be varied. The quality of the picture is going to be varied. People are going to take, pictures of their KTP on a background screen where they're like their words over the place, and other problems like that. So in general, your data is going to be really dirty. And the challenge, and I think you rightly kind of pointed this out, is the pre-processing, because if you don't pre-process it properly, you're going to get like all kinds of crappy results. So to give you like a quick run through of the pre-processing that I did, so the first step would be you get your picture. The second step would be to identify the face, because most KTPs would have their picture. So I use a separate model to detect the face, and from there I have some calculations such that I would crop the first part and the second part, so you kind of get like almost the rectangle. Then I would use another object detector that specifically trains on detecting identification cards, and from the bounding box I further crop the card. So up to this pre-processing step, you would relatively have a nice cropped KTP image. And from there, you do your various computer vision tricks, like converting it to grayscale, doing dilation, erosion, and all that kind of other fancy tricks. And when you're done, then yes, you send it over to the OCR engine. And even that, requires a couple of different ensemble of machine learning models. But you just ask for the pre-processing, so yeah, pre-processing.
All right. Thank you for the answer. And is there another question we have today? Okay, there's another one.
Yes,
How
so
DKatalis handle liveness? Okay.
right. So this problem, this challenge is coming up soon. We are going to solve this problem soon. So I'm looking forward to doing this because this is a very interesting problem to solve. And especially when now people have like masks and you can do weird things with your mask and yeah. So this will be fun. Next time we'll give a talk once we figure this out.
Okay, there will be a special talk about it.
Exactly.
All right, I think that question marked the end of our Q&A session. And before our closing, I'd like to have a photo session first. So everyone give thumbs up for our speakers, and let's have a picture. 1, 2, smile. All right, I think we have our picture. Okay, thank you so much, Benjamin, and also Varun for today's session. It was incredible. May we meet again in another talk session. And thank you everyone yang sudah menghadiri acara GDG Jakarta Talk Series kali ini. Nantikan acara GDG Jakarta selanjutnya ya. Bye-bye everyone. Stay healthy.
Happy Friday, everybody.
Yes, happy Friday.
Oh yeah, happy Friday. Happy weekend.
All right, bye-bye.
Bye Benjamin. Bye Varun. See you.